Dear student, in the last class we have discussed about the physical properties of haloalkanes, right? So in these physical properties of haloalkanes, so the first point was that means it is totally based on the boiling point we have discussed. So the boiling point of the haloalkanes are more, right? Why? Because simply first of all the statement is the haloalkanes are having a more boiling point. That means, see, we will not go in branch in other all the things, but generally the haloalkanes are having more boiling point. Why? Because generally when we can give a just example that in haloalkane, right? In any haloalkane, you can take primary, secondary, or tertiary. We will be having a single bond around the carbon. So as a result, as I said, the single bond are sigma bonds, and the sigma bonds are very very strong bonds. This is the first point. Coming to the later in the case of halogen, so very next point only we have discussed about boiling point increases with the increase in the size of halogen or the number of halogens. Everything I have given in the last class, you just try to see those things, and in the examination they will ask you by giving different example, and write the sequence or order of the following compounds. That means, see, as compared to all the halogens, iodine is having a more size as compared to the bromine. Bromine is having a more size as compared to the chlorine, and least size, which is the halogen, is nothing but fluorine, one we can say. And the reactivity order will be like this: Ri is having more boiling point than the RBr, right? RBr is having more boiling point than the RCl, and RCl is having more boiling point than the fluorine. Why? Because as per our statement, what we said, the boiling point of the haloalkane goes on increases as the size of the halogen increases. So that means iodine is the having most, more size among the halogens. So that's why iodine, and then after bromine, and then chlorine, and then fluorine. Why? Because based on the size only we have given the order. And one more thing, if they won't ask like very simple question of about boiling point, then they might introduce some difficulties, like by giving two to three different what halogens. So in that case, the alkyl group which is having more halogens, you give first preference. As the number of halogen increases, boiling point will also goes on increases. In the last class only I have said you. So these points are very simple to write it in your theory examination, but in case of competitive examination, these are the some hints which I have given in the last class itself, right? So try to go with those things, right? The third point is, in case of isomers with increase in the chain length, the boiling point increases, of course, right? It is very quite common process, right? In isomers, as the chain length increases, that means isomer means two bodies with same molecular formula. That means we can write a two different structure for a single molecular formula. In the last year only we have studied about those things: positional, right, functional, chain isomerism. That means any isomers, if they increases their chain length, right, if they increases their chain length, then definitely what happens, the boiling point will also increases. With increase in branching, boiling point decreases. See, this is very important. Say for example, we will take one example as this. So CH3, CH2, 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 CH3. See, you just count it out. Why? Because we are talking about, in third point, we are talking about the isomers, right? So isomers are, that means, as the in isomers, in case of isomers, as the chain length increases, boiling point increases. As in isomers, in isomers, as chain length increases, boiling point also increases, right? Now, see the isomer 3, 2, 5, 5, 10, 14. H14, 6. C6H14 is our molecular formula of this compound, right? So now I am going to write a isomer. Isomer means one we can introduce a chain, right? So see here, CH3, CH2, 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 right? CH3, 1, 2, 3, 4, 5, and here one we can write CH3, sorry, this one. So now you count 3, 2, 5, 3, 3, 3, 9, 10, 14. So okay, C6H14 again, the same molecular formula. The next point in this same particular point is, in case of isomers, see, very important point it is. In case of isomers means one we can write at more than two structures, right? You already know about that. In case of isomers, as the chain length increases, boiling point will also increases. But as the branch increases, in same point only, in isomer only, as in isomer, you can say in isomer, as branches increases, very important, boiling point decreases, which is very important. I will give a reason, you don't worry about it, but try to understand this point. In case of isomer, as the chain length increases, definitely what happens there, the boiling point will also goes on increases. The reason is, I am saying a reason here, they have not given any reason, but the reason is, as the length increases, the number of sigma bond also goes on increases, and hyperconjugation will also increases. Hyperconjugation means transfer of sigma bond, right? So you go with that point, right? So now, as the chain length increases, definitely what happens in general, I'm saying, the number of sigma bond will also goes on increases. So that's why what happens, chain length, in case of isomer, it is in case of isomer only. In case of isomer, as the chain length increases, boiling point will also goes on increases. But in isomer itself, branches, sorry, if branches comes in existence, sorry, in isomer, as branches increases, right? If the branches increases, then boiling point decreases. Why? Right? We are having the same molecular formula, same number of sigma bonds, same number of, there will be no pi bond, but same number of carbon, same number of hydrogen. That means definitely the number of what sigma bond will also same. But what happens here? Branch means it is not in the skeleton, parental skeleton, right? This is the, see, while naming, according to the IPAC system, while naming, what we will do, we will just identify first a longest chain, and rest all are what, branch or a functional group. So in this case, what happens, the parental chain only comes in a countation, right? We count only parent chain, we won't bother about what, this branch. As the branches increases, that means these branches can very easily remove. Why? Because they are not in the strong parental chain. See, if it is a tree, right? It is a bark of tree means it is a branch. See, say for example, I cannot remove this part very easily. This part, right? This part I cannot remove. Why? Because it is a parent. That means it is the base of that tree. But for branch, what I can do very easily, I can remove, right? In the same way, it is not in the parent chain. So that's why this part, that means branched part, one we can easily remove. So it will not come in the consideration of boiling point. That means only now we should count the number of sigma bond, not the carbon, the number of sigma bonds in only parental chains. Why? Because this CH3 is not in the parental skeleton. So that's why this can be very easily removed. So thus, in case of isomer only, as the branches increases, boiling point decreases. Why? Because as branches increases, the parental skeleton goes on decreases. That is the main point. So now see here, in this case, even though they are having the same molecular formula, but in this case, what is the main thing is there are 6 carbon atoms in the chain. But here, what happened? Because of branch, the number of carbon atoms were decreased, right? So because the number of carbon atoms are decreased in the parental chain, one we can say the height is decreased, right? So now one we can say that the as the number of branches increases, the boiling point always goes on decreases. So I am going in very depth of about this. Why? Because these points are very important for again for your competitive examinations, right? So now, and after having a good idea about these things, one you can very easily remember the next things whatever will come under this chapter, right? So now alkyl halides are insoluble in water. These are the common points. So the fourth point is alkyl halides. Of course, alkyl halides are insoluble in water. That means definitely when we can say these alkyl halides, I mean haloalkanes, they are not soluble in the water molecule. Solid, but they might be soluble in different organic solvents such as benzene, ether, toluene, but they are insoluble in water. Why? Because they couldn't able to make a hydrogen bonding with the water molecule. Whenever we mix these alkyl halides with the water molecule, they unable to form a bond very easily. So that's why because of presence of carbon itself, one we can say, and because of presence of I mean these haloalkanes are stable. So that's why they might not undergo very easily into the reaction. So they will not be soluble in water, but they might be soluble in organic solvents such as benzene, one we can say, toluene, ether, etc. Right? So the density of alkyl halides with common alkyl group is following order. The density. So the density of alkyl halide or halogen. Alkyl halides are nothing but haloalkanes, right? Density of alkyl halide, the order of density, one we can say, the order of density of alkyl halide is as follows, right? So density means, right? So see here, density means what? Density means mass. Density is directly proportional to mass, right? Mass by volume, what we say, d is equal to mass by volume. So now see here, density, the mass, if mass increases when the atomic number increases, so that means among the all halogens, I mean among fluorine, chlorine, bromine and iodine, among the 4 halogens, which one will be having more mass? Definitely iodine. So thus its order will be, right, iodine is having more mass, that means density, as compared to the bromine. Bromine is having more mass as compared to the chlorine, and chlorine is having more mass as compared to the fluorine, right? So which is it is very simple. Why? Because it is based on the mass. That means the as the atomic number increases, definitely the mass of that particular element will also goes on increases as compared to among these four, as compared to fluorine, chlorine, bromine and iodine. Iodine is having more atomic number or mass. So thus, because of its size, one we can say. So iodine is having more density as compared to bromine, and bromine is having more density as compared to the chlorine, and chlorine is having more density as compared to the fluorine. With increase in the size of halogen atom, the bond length increases, but the strength decreases. This point is also very important here, students. So now, see here, as the this point, the fifth or sixth point, as the size of halogen increases, as the size of halogen increases, comma, bond length increases, bond length increases, but bond strength decreases. Very important and very simple concept it is. Strength decreases. See, what is the concept, actual concept? So now, if we see these, see, there are two things: bond length and bond strength. Right? So now, as the size increases, what happens? Definitely, the bond R and X. See, so X may be what? Fluorine, chlorine, bromine, or else iodine. So among these, the size of this iodine is more as compared to bromine, chlorine, fluorine, as you know. So now, what is the statement here? As the size of halogen increases, bond length also increases. See, because iodine is having bigger size, so that's why, because of its size, right, like this 4 and 5 cells are involved nearly. So thus the strength, that means the bond length, that means the distance between two atoms, nucleus of a two atom, is nothing but what? More, right? But in case of RF, that means a small sized halogen, it will be very small. Why? Because it is having only nearly two cells only, right? So that means the nucleus to nucleus distance will be very small. That means as the size of halogen increases, the bond length goes on increases, but it is just opposite. Bond strength, strength means strongness. Strength is nothing but strongness or toughness. So now, as the bond length increases, bond strength goes on increases. I will just give an example. See, in case of Ri, right, the size is more. I will give just two examples. And in case of RF, the size is very small. In the introduction class only, I have introduced this point, right? So now, say for example, if I give you this pen to remove, if I ask you to remove, then your first imagination is to whether I can handle it properly or not. If I am able to handle it properly, then one we can very easily remove the bond. The same thing will happen over here. See, if the bond length is more, then one I can very easily remove this bond. Why? Because I am having enough space to handle with my hands. Right? This is the one case. If the size decreases, then see here. What is the case? If the size decreases, the R and F, between R and F, this is the bond length. That means what happens if it is not a proper handling of this instrument, then one we cannot break it very easily. So that's why bond strength decreases. As the bond length increases, bond strength definitely decreases. Why? Because one we can very easily remove those bonds, right? You just imagine in your way, definitely you will come to know the more and more point of about it, right? So dear student, this is all about today's class. In the next class, we will discuss about the next part of this chapter, right? Thank you.